Australia. Wow. And also let me know what exactly you're looking forward to from the session so that I can also make sure that I spend some time on those areas as well. Um, and how many of you are well versed with Azure? Like you know Azure in and out and you're able to navigate through Azure. People are from Sri Lanka. Hello, Adelaide. Wow, T20 World Cup starting there. Australia. Wow, I'm looking forward to that. Okay, I see to scale up in a cost effective way. Okay, we can discuss that. Okay, not well versed in Azure, just started. Okay, I'm going to spend a lot of time on specifically building scalable containers based microservices. Nice. Hosting options. Yes, of course. I'm going to spend a lot of time in discussing how you can host. You want me to spend time on dappers? Yes, I'll spend some time on dappers. Let's do that. Okay, deployment slots. We'll touch upon that. So how many of you are founders here? Like you're already a startup, you already have a prototype and you're working, or if you're planning to be a founder and you're almost looking forward to building something and all that stuff. How many of you are here on that? Got it. Mm-hmm. Nice. Mm-hmm. Wow, nice. There are a couple of founders. I see. Nice. Okay, there is a mix of audience here. Uh, so we have founders, we have startup developers, we have wannabe founders as well, which is amazing, which is great. And should we get started, Srijesh and Path?
Yep. Just give me a heads up.
I'm all
We
up.
ready? Okay.
Yep.
Shijesh, I think the recording is already started. So we start the event. Hello, everyone. Good morning, good afternoon, good evening, globally, who all are joining us at the Reactor Bangalore. I am Parth Varu, Event Program Manager for Microsoft Reactor Bangalore. Before we begin, please take a moment to read our code of conduct. We are all here to learn together. So please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Vivek, our speaker for today's session. Vivek is a technophile and an open source contributor with around 17 years of experience in the software industry and works at Microsoft as Senior Cloud Advocate. Over to Vivek to begin the session.
Yeah, Pat, thanks for the intro. Let me share my screen. Let me know if you are able to see my screen.
Yep,
You're
I can
able
see
to
your
write?
screen. Yes.
Perfect. Um, so today's a session is going to be little. Uh, I'm going to cover end to end, so a lot of stuff. So please be with me on this. What I will do before even starting the session is to make sure that you ask questions at the end. Please note down the questions because if you keep posting the questions, I might lose those questions as well. So keep your questions till the end so that you know I can take a break in between and ask you for questions on a couple of these things, and then we can obviously go and answer those questions as well. But I'll try to address a couple of things which are already there in the chat while I'm talking about those set of services. And let's begin. So for those of you who don't know me, I'm Vivek. Been in a software industry for over 17 years and been a developer and been an architect, been in the startup world, been founder myself, and been in the consulting and strategy and investment role at Microsoft. Currently, I'm senior cloud advocate at Microsoft. You can connect with me at these digital coordinates, and if you have any questions after the session, do reach out to me on LinkedIn. If you need any help in building, do reach out to me. I'll try and connect you to the right set of people as well. So, and given that, the way I'm structured this talk is we're going to see most of these services, some of them hands-on. We will deploy and we will do complete hands-on of these services. But from Azure application platform perspective, if you see, uh, you have infrastructure as a service, right? And virtual machine, and you have container platforms, Azure Kubernetes service. We have platform as a service, which some of you talked about. Azure App Service, container apps, which is a pretty interesting one. Spring apps for Spring Boot applications, and function app to build functions. We're going to deep dive into all of these things, static web app, everything. And obviously databases, different set of databases with different set of capabilities, and Cosmos DB has been the amazing thing, and even having to enable with the Postgres as well from the build announcement. I mean, from the Ignite announcement we had. And there are integrated platforms like cognitive services and Azure Active Directories and policies and other things. So we will obviously, while we are discussing, I'll just go through all of these things as well. And there are a couple of toolings, and I'm going to pretty much use Visual Studio Code and GitHub to show you a couple of things, what we are going to do and how we are going to achieve a couple of application deployment here, right? So even before I go there, I noticed a couple of them are new to Azure, a couple of them are already pro in Azure, and even if you're pro in Azure, probably this might be a real good one to understand Azure resource, how exactly Azure is structured, right? So everything in Azure is a resource. So basically, whatever you define, whatever you build, if you see this, it's completely start with a resource. Say, for example, if if you're spinning up a virtual box, it's a resource. If you're spinning up a PaaS layer, which is Azure App Service, it's a resource, and it is logically grouped into a resource group. This is a logical grouping. So basically, if you have you are saying, okay, these all of these resources belongs to developer environment, all of these resources to belongs to uh, QA environments, all of these resources belongs to production. So I will only focus on grouping these things into resource groups. Okay, and now it's more about not just about resource group. It's also about putting everything into logically structuring it into subscription. So subscription is basically nothing but you have subscribed to some amount. So you have a bucket of $10,000 to spend, and that is the subscription you have, and you are actually spending on top of that. And to logically group it, that's where you have as a subscription. And under as a subscription, you can have multiple resource groups, and within that resource groups, you can have multiple resources. So that's how it is structured. And it's not just the way it is structured. uh, it has a REST API endpoint and resource manager in between, where it interacts with subscription, resource group, and resources. Let us take an example here. I just want to show you what ways to access, and some of these things we will be using in pretty much in different ways in the discussion. um, so Azure PowerShell, okay, so it's one kind of a client where you can access these APIs, resource groups, and then make a call to spin up a virtual box, or to spin up Azure App Service, or to spin up Azure function, right? And you can also use Azure Portal, you can use Azure CLI to do it, and obviously through Visual Studio Code, through the API calling, you can obviously directly call these endpoints, right? So this is how it is structured, and this is how it calls, and this is how it works. There is no direct interaction between the services. There is something called as providers, and there is Azure Resource Group Manager, which is sits on top of this API REST endpoint. And whenever you make a call from Azure PowerShell, there is a REST API endpoint, and Resource Group Manager actually gets invoked, and it calls a virtual box, and then resources triggered under the subscription. So this is how it works. Okay, so there is a call which it makes, and this call will go to the virtual box. I want to build a virtual box, and then it resource gets created under the Azure subscription. And this is the basic structure. Okay, and bunch of other things gets involved. Obviously, Azure Active Directory. This is to make sure who is calling it, who is that person really invoking these services, right? So somebody has to invoke the service. So who is that? So it has to verify. So that is where all of these subscriptions and other things comes under tenants, and each of these tenants has subscriptions, and it is trusted. Once the trust is been built, then only these execution happen. So that is how you can see the structure. So this is a simple structure of how exactly this resource group uh, gets set up, right? And if you see now, it's very simple. Each tenant is associated to an Azure subscription, and resource group is set up. So REST API, it calls here. There is a trust which has been built, and then it goes into the subscription and resources, and then the resource, which is the virtual machine, gets created through the API call. Okay, so now um, obviously there is role-based access. Not everyone can go ahead and create virtual boxes in production, right? So somebody has to control who is going to create it. So that is where Azure role-based access come into picture. And once Azure role-based access has been set up, the thing is it's not just about trust, it's also about whether the person has the role to create a virtual box in the production environment, or in the QA environment, or in the developer environment. So basically, it is controlling how this execution is happening, and you are the controller, right? You are given access to rights on certain people to do certain roles, and this is where they can perform actions. And there is policies. Based on policies only, the resources gets approved. For example, what is a policy? It's basically I'm a DevOps engineer, and there is a DevOps head, and DevOps engineer has access to create resources, but there has to be a limit on how many machines he can create, how many services he can go ahead and create. That control is put on through the policies. I have access to go and create virtual boxes, but do I have access to create virtual boxes of these many set of virtual CPUs and other things, and then I'm able to create it or not? So that's something which is which is the missing part here. And obviously resource limit, which I told you, there is policies, there is limit as in this many boxes, and this is the finance limit as well. We cannot cross this limit to make sure that I'm not spending more. So here you can put a limit saying, oh, I can only spend this month $1,000 on QA environment, and this is the resource policy, and these are the machines only I can deploy, and these are the set of people only can deploy this. And that's how Azure is set up, and that's how you should be setting up this Azure as well. So why I'm talking about this is because most of the wannabe founders and already founders, they usually tend to go ahead and create resources. It's but will not spend much time on understanding the role-based access, how to limit, so that you can limit the usage, limit the accesses, and also put some policies around your environments, your subscription, so that you don't spend more. I saw that question there. There was one question which said, how do I make sure that I use Azure with less pay and making sure that I'm still scaling, I'm still good, but also I'm also controlling how the money is being spent. So this is how you can do it, and bunch of things are already available here. Again, finance commitment, which I said, these are all limits which you can apply here. So this is a basic introduction of how resource access management work in Azure. And just take a look at this. I'm going to share this link in the chat so that you can also go through it wherever you're free. So I'm just sharing that thing. Okay, cool. So let me go back to my slide. So from today's agenda, I cannot cover all of these things, right? So a couple of things I'm going to cover is from a code base perspective. Say you have the code and how well you can use the code. Um, Code is it is not containerized. That's what I meant when you have the code. It's not containerized. It's just a simple code you have written. How you can deploy it on Azure App Service, how you can deploy a code on functions, and why the functions is different, and how you can use it, how you can use it. And we'll see some use cases. I'll show you some use cases in terms of functions. And Azure Static Web App, I'll show you some use cases of Azure Static Web App and how to get started with it. And from a container perspective, I will go deep dive into Azure Container Apps and understand how you can exactly build microservice applications, how you can make use of Keda, how you can make use of Dappers, so that you can scale. Obviously, when you are using container apps, container registry is part of it, and Kubernetes service for making sure you have a very good management of workloads, and how you can use that as well. And I'll spend some time on the insights and monitoring while I'm doing all of these things. And we will see Azure AI as well, the cognitive services, the we'll see a demos of all of these things, custom vision, and all of these things. So we will build it, and we will see how exactly this all fits into the bucket, right? So it's a packed agenda actually. There is bunch of demos there, and there's a bunch of things which I'm going to do, from code to containers to AI. So stay with me, and we will obviously go into Q&A at the end of the session. Okay, so we'll start with Azure App Service and understand what exactly Azure App Services are. Even before we go there, I'll just share my collection. So there is a collection which I have. I think Parth will share the link in the chat. But I have actually created a collection of learning material, which is basically has the all the things which I am doing, and which will give you a support in terms of after this session how you can go back and learn from all of these things. So let me start with this. How do you host a uh, you know uh, Azure App Service, right? So so it's Azure App Service is very simple. You want to make sure, I'll also show it here, but you want to make sure how you want to run an application and make use best use of infrastructure, right? And you're not exactly going and spinning up a virtual box, and you're not spending time in patching and building that and building slots and other things. There was a somebody point out how to use deployment slots and other things, right? So there is a way to build this, and it is pretty easy to manage infrastructure. So it's but it is a dedicated infrastructure. You should know what is will be the traffic on your system, and it is a dedicated infrastructure. I'm not telling you cannot use containers with app service. You can use containers with app service, and there was a question in the chat which said, what is the difference between Azure App Service and container instance, right? So container instance is built only for the container whenever it is used, but Azure App Service, you have a dedicated service. So let us go back and get started with app service. So I'll go here and search for app service. I hope you're able to see the screen. Okay, so I'm creating a new app service. Okay, so right now there is no code which is there. It's basically a simple app service which I'm deploying. uh, if you want to go back and execute the same thing, it's there here. You can go and create through web portal, how exactly to create, what are the steps, everything is available here. Okay, so I'm just doing it on my own here. So let me say we'll take fundamentals of startup, and we will name it something called as bike app. Okay. See, if you see here, there are a bunch of options to publish the code. One is Docker, one is static web app, right? And I'm just using code, and I'm selecting the uh, my runtime stack. Say it could be Python 10, and operating system is this one, Linux, and I'm using Central US, and there's a plan. So this is the most important SKU and the plan. So here, if you click on the plan, you can create a new plan name called uh, bike app plan. Okay, so let us go create bike app plan and change this. So this is where it becomes interesting. If you're a startup, if you are a if you're a enthusiastic who's trying to build something new and you're trying to deploy something new, the F1 and B1, here are the two different things which is you can use. It is very low in the cost per month, and if it is F1, you get almost 60 minutes per day compute free, and you can obviously test and build and do a bunch of things with your code, and that is how you can build with it. And if you are in production, if you choose different set of things, this is where you can select. You should be knowing what exactly the compute you require, right? This is the now basically basically the compute you should already know, and these are dedicated computes. And this is the difference between the serverless, the function Azure functions we have from the consumption plan versus the app service plan which we have. This is where you dedicate. This the other place you don't dedicate anything. You are basically going and executing it. So if you see here, Azure Compute Units, which is dedicated compute resources which is being set up. So this is the dedicated compute resource. Okay, so that's the major difference between app service and the functions app. Okay, and bunch of things is provided to you. If you see here, you can add scale and other things, but also in production, if you go, a bunch of features gets enabled. Say first one, if I am picking, there are a couple of things. Auto scaling up to 20 instance. You can scale this up to 20 instance, and staging slots. This is the interesting one. Somebody asked how to do it. So when you deploy app service, you can actually see the slots. You can deploy it to either to production. You can deploy it to as a testing. You can deploy it to QA. You can create slots within this and use it for testing purpose. And there is traffic management as well available for you, and obviously backups and storage and memory you can obviously use different set of things. So if I go back and choose the first one itself, which is this much is the estimate, right? It's almost like 6,000 rupees per month Indian currency. And if you just go and apply, it this gets changed. And you have, there is obviously redundancy and other things where your service plan is available in different zones and other things where it, even if it fails, the other zone gets enabled, that you can enable it here. And obviously deployment, there's a amazing support for deployment as well. So as for example, you already have the code and you are enabling continuous deployment, and you are selecting which organization you are working from, and there is repositories which you want to pick, and then there is branch which you want to pick, and then just go back and GitHub workflow gets generated, and you can directly deploy from there. So as of now, I'm not deploying anything from there. I'm just you know going back and creating app service, right? So this is application insights. As I told you, on the application insights, if you have a better thing, you can obviously enable performance monitoring, and that is something which you can enable once you have built it. So this is where you create it. So I've already created one app. So this is a simple initialization of that app. So if you see this module as well, I'll come back to the module. So this is a simple module which where you will go and create an app. So we have already created that app. There is a sandbox as well. So if you want to play around, you can play around with these learn modules. There is a sandbox. You can easily go back to the sandbox and uh, play around with couple of things. And you know, um, once it is built, we can see the preview. So it will be like this. So wow, you got started and other things. And again, when you go back and bootstrap something, we will go and build some app and see how exactly that works, right? Let me go here. So here is my deployment, right? So here it is running, and it has nothing actually. There is no code which is there. All I need to do is to push my code, and this is the one which I wanted to run. So as of now, it is up and running, but I don't have the code. So let me run the code. So let me go to the uh, where is my code? There is no code. So I have best bike app. There's no code. Touch requirement.txt. Touch application.py. Okay. So I'm just writing a simple code. Let me open the code. So Flask app. I'm going to build and deploy a Flask app just like how it is there here. So I'm just going to copy the code and deploy it, and you can see my Python is set to 10. Okay, so here is my code. You can see my screen better. Right, so I'm just you know, uh, writing hello bike app. Say you have a simple application. I have requirement, Flask app ready. Everything is ready. Simple. All I need to do now is to deploy this application onto the app service, which I already have. This is the app service which I have. I want to deploy it there, right? So how do I deploy it there? So all we need to do is to run a couple of commands. How to run the command? So let me go to the writing the code and implementing it, and we'll change the code. What do you say? We'll change it to this instead, right? We're doing HTML. Uh, so all we need to do now is to deploy the code. Everything is there in this learn module as well. So there are different ways to deploy, as I told you. It gets from directly from GitHub. You can also do it with FTP. You can also drop it into the Dropbox and run it. There is a support for Azure DevOps as well. You can deploy it through that. And obviously, manual deployment, there is a command line already available. So I'll just show you how to do it through command. So it's very simple. Let me copy this as a web app, right? Let me see if I have Shift R, easy web app. Okay. Am I in the best bike thing? Okay. There is AC web app. So app name is what? This is not my app name. You can see my screen, right? All good?
Yep, Vivek, all good.
Okay. Oops. I'll just sort of clear this. Mhm. Let me go back and say reverse and say AZ. Okay. Now we can see. So this is not my bike name. What should be my bike name? So where is my bike name? Bike app name. This is my bike app name, right? So I'll just give my bike app name, and my resource group is the same, and my plan is different, right? What is my plan? My plan is name is this, right? So you need to know what is your plan name, and this is wrong. Central US SKU. What is my SKU? P1. Did I pick P1? Well, I did. Yeah, I think so. P1. P1 and what is it called? I forgot the name of the uh okay. Um so it won't pick the it won't pick the what is the code, right? So basically if you run this now, I hope it will pick the which programming language I'm running, or else I will have to specify the programming language and the uh, something is missing. Web app name, location name. Yeah. Oh, it is like this. SKU. It's wrong. Right. Let me see if that picks. No, it does not. So let us go back and read this reference document. It has to have one important thing. This uh, when we created which one? While we created a new resource, where did it go? Compute. Where did my resource go? Okay. Well, we used the runtime stack. Huh? Okay. It's here. It's runtime Python 3.10. Okay. That is which one I was using. B1, B2. Is it something like that? Okay. So now it says it's already exists. So it is going to push my code uh, to the service plan. So it is basically creating a zip file of this and sending this across. So this is exactly how you can build and deploy. So I've already done one deployment of that. So which is already there for the demo purpose only. If I go home and app service, you can see there is a bike app which is already running uh, in the basic plan, and you can see there's exactly the same app which I've deployed, and this is also getting deployed. So it takes some time to deploy and come up. So what I have done is very simple. I had the code. If you see, I had simple code, and you can see all thing running. And here is the I copied it wrong. Okay, so let me go back and try and see if this works. Okay, so this is the simple app which we built. So I had a simple code, Flask app, and I was it is not containerized, nothing. So I just pick it up and just go there and deploy it, and it's all working fine. So now I can keep developing this, and as I told you, if you go back here and go to your deployment center, you can you can basically build a couple of things. So you can also set up the GitHub, which I was showing you, and deployment slot is where you can add slots, different slots. So I need to upgrade to the very premium plan to get this different slots, and I didn't add it while creating it. So I should have added it, and I would have easily got it. So I need to upgrade it, and if I click on upgrade, and it goes there, and I can go back and say, okay, this is where I am, and I want deployment slots, and apply. Right. So a couple of things which I can apply. Cool. So uh, this is about the app service. So we were able to build and deploy app service. So you can go back and read through it. I'll just go back to the slide and talk to you about the functions we have. So there is no much difference between an app service and the function. It's still the code. There also code, here also code. It's all about consumption plan. So there is a consumption plan which is there, and you need to go back and consume couple of things. And here is functions which is based on serverless. We all know, right, when we all started like 16 years back, 15 years back, we were talking about how going and building something on the machines directly, where we were getting into a room and deploying stuff, and after that we were able to access through internet, which is infrastructure as a service, and couple of services became passless like Azure App Service, where dedicated servers were given to you, but you need to know what should be the size. You need to pay for the dedicated service like Azure App Service, which is a dedicated compute. But here, you're not basically paying for the compute. Basically, whenever your compute is being used, then only you're paying, and you don't have to manage the infrastructure. The security, the upgrade, the reliability, the availability is all taken care by the infrastructure. And then there is auto scaling. You can replicate this particular code to the highest level, right? So bunch of things which you can do here. Um, so the structure wise, it is always through an event driven application, right? So basically you're event driven, so there is a trigger which is happening, and when you're triggering something, there is input binding and output binding. What do you mean by input binding? That is, you're getting data from either from Cosmos DB or from third party things, or through blob storage, and you're actually output binding it to different set of things. It could be a logic apps, it could be a different set of databases and other things, right? That's how this has been structured, and this is works. And trigger is very important here. And in this particular programming model, which is Azure Functions, serverless is a concept, Azure Function is a programming model. It is a structure, it is a way to program your application. And triggering is nothing but, there are bunch of events which can happen. That if something changes in the Cosmos DB or database, there is an event. If there is a HTTP request which comes in, there is an event. If there is time triggered, that means you have cron jobs running, it's an event. And if you have event bus, which is nothing but a queues, if messages are coming into the queues, then that is also an event. So basically all of these things are called triggers. You can also have build your own custom trigger. And basically this trigger actually runs and executes a business logic, and your logic, you would have set it for different set of things, and that's how things work here. And basically that's called input binding, and then there is output binding where the data is being transferred to. So let me go back, and let us go back and see how this works, right? So as of now, what we did, we had a code, we wrote it, and we deployed it, and it was deployed directly to app service, and you can see it is running in the app service plan. And you can keep changing this code, and you can keep building on top of this code, and you can keep running it as a one API, and or you can run it as a different set of API service, right? And that is something which you can definitely do. And let me go back and show you how you can build a function. Say for function to be built, let me close this up. Function to be built, you need to have a local workspace. The most advantageous thing is about function, it gives you a structure. Function, Azure function, it's a programming model which I told you. It gives you a structure. So when you create it in the workspace, you can basically test it locally and make sure that it is all working locally, and also you can deploy it to the to the main function. Okay, so let us go back here and let's see how to get started with it. I have a local workspace. Probably this is where it will get built. So I'll go and say create the folder. Yes, I'll create something in the local workspace, and I am looking at Python as the code. And let me select Python. Here is the trigger which I talked about. There are a bunch of triggers. There is HTTP trigger, time trigger, blob storage trigger, Cosmos DB trigger, and durable functions. I'll come to that. It is activity between two to three different functions. If maintaining the state, if you're asking about state, functions are usually stateless, but here is where you can use functions for state management as well. Those are called as durable functions, and there is bunch of other triggers which is already there. So let me check, uh, take the HTTP trigger and say okay, let's go bike app design. So something I'm taking, and it has different level of authorization. I'm giving anonymous because anybody can access this function. It's basically there, it exists with something, so it's overwrite. Let me overwrite it, it's okay. So basically I've created a function, right? I'm closing this off. So you can see this is the code which is there in the function. So if you come here, this is the structure. So you see this, this is the structure of the function which gets created there, right? So basically what is it creating is, obviously I've created on top of this application py and other things. I could have used different folder. If you see here, it's basically the main function, main thing which is running. Functions is nothing but what you call in C++, in other places, right? In Java and everywhere, that it does a small job, and it does when it is called. So that is the concept. So basically, you have a small API which is running, and if you notice, I selected Python, and it created a Python structure. So basically, it created a Python structure. So requirements.txt is what we created. And if you see a couple of things, uh, it is already listed here. If you go back and create a Node.js app, it will create a structure with packet.json, and it will give you that structure. So that is how these functions are built. And you can see from here, Azure, if I go back to my Azure, you go refresh this, you can see here, this is how it is. And you can uh, go back and try and debug this. I hope it will run. So I'm debugging this locally actually. So I've just executed functions. So I do have function core tools, all the Python versions, required versions being installed locally. There is something which is running in localhost. So I just created a function. I have some code which is by default code, and I can copy this one, and I'll show you how to execute this one. So it's locally debugged. So basically, I go here, name is equal to um, Vivek Reactor session, right? So it says hello Vivek reactor session. So this is the execution it is providing, right? It is locally executed right now. It is not on the on the cloud. It is basically developed locally, and it is the code is local to whatever we are executing. So I'm coming out of debug. So here is where I'm disconnecting from the debug. So here is the debugger. You go and select attach to Python function and debug it. It will just run it, right? So that's a simple local way of doing it. Now if I go back here and say functions, there is nothing has been created. So I go and say create a function app in Azure, and I'm going to go and say okay, enter global name, wiki bike test, and it will ask for the stack. I will use this Python is where I'm using, Central US. So it's creating an app for me currently. This is on the Azure side. So here is where my Azure extensions, and the app has been created on the Azure side, and I have the local workspace for the function. So I've just created a function app on the local workspace. So it's not that there is no server at the backend in serverless, right? There is a server. It's just that you are only focusing on the business logic, and you're just going there and saying I want to run a function, and you are set a this is a programming model which has been given to you. The programming model is basically the triggers and the structure and all kinds of support you require as a developer to develop and execute this code. And once you're ready, you can push this app to the cloud with the function app once it is created. And you can see how exactly this is running in the cloud, right? The way we execute an API, the Azure App Service, right? It's just that it is in the consumption plan, where that means uh, if the traffic is coming to my function app, then only you are paying for it. There is no dedicated backend servers, but in the app service you have a dedicated compute where you have set this is the compute I need to run couple of things and slots and other stuff, right? So that is exactly how this has been structured. So here is my uh, my app which has been created. So that's not what I want, right? I want to deploy my code there. The code is still in the local. It is not there on the function app. So right now, what I'll do is basically go and open my go and select Azure function deploy to function deploy to function app in the Visual Studio Code, and it will show which one to deploy. You want to deploy it here. I'll say yes, I want to deploy it, my code there. It will tell I'm going to overwrite whatever is there. So yes, go ahead and overwrite. There is no code there, so I want it to be overwritten by the original code. So the original code which is there on my local laptop is getting deployed to the functions. So it will take some time though while it is there. Uh, while it is getting deployed, I just want to go through couple of scenarios where you're going to use functions, right? So there is a web application backend, there's a mobile application backend, there's IoT backends, right? So for example, one of the example which I can give you as a web application backend, you are making online ordering and other things, we do it every day, and you request something, and the request is going into service bus, and this is not a HTTP trigger, this is a service bus trigger. So the function which is there, whenever there is a message which comes in, whenever there is a request comes into the service bus, a function gets triggered and data is stored in a database which is Cosmos DB here in an example. So there are multiple examples like this mobile application backend. So there is you go out with friends and other people, and you ask for them to share money once we have celebrated something, right? So there is a mobile app which is there, and then you're calling some functions, and there is Cosmos DB which is there. So data is getting stored in one of the function is HTTP trigger, but the other function which is there here, which is this one, is a Cosmos DB trigger. So it's a combination of two different functions here. One is where you are actually going and deploying a simple function, which is the HTTP trigger. The other is obviously a Cosmos DB, and also you're using a notification service. So all of these are event driven. If you see, there is an event which is happening, there's an event which is coming here, and then it is again a new event which is triggering the other function due to the change in the Cosmos DB, right? So this is the where you can build, and the IoT services as well. If you're building a startup which is based on IoT, a lot of data gets built and deployed onto the IoT hub. And if you're using Azure IoT hub, and then through that, you can also call the functions and use logic apps to process it, and also create repair work, right? For example, you are working in a environment where all the lights are IoT devices, and basically one of them are defected, and it creates a process. You have created an automated process to know that a bulb has gone wrong and you need to replace the bulb, and a function gets triggered based on the some of the conditions which is getting into the data, and you're actually running a logic app to even connect to the third party tools which is like Zendesk to enable a request in the device repair and other things, right? So the bunch of things in the conversation about APIs and real-time file processing if you're doing. Again, these are all blob storage function triggers, and that is where you're triggering to get some cognitive services. And then real-time processing, again, you're processing data, and then based on some conditions you're actually triggering these process. A lot of things, examples which I can show here. um, Before I go to the next segment, uh, yeah, so here is where uh, my code has been deployed, my API has been deployed. So if I go back now uh, to the same, this is local, but I'm going to change it from local to name is equal to Vivek. So if you see here, this has changed, right? So this is running on my function. So this was very simple, right? I just created an API without any hassle, right? I just did it on the local. I just created a template. It gave me a template with requirement.txt, with the Python file structure, everything. All I need to do is to write code for my API. I'm focused on writing my business logic. I just push that and my function is up and running. So that's how you can build async functions, and that's how you can go back and deploy these things as well. And yep, um, I'll finish this static web app. I know there are a bunch of questions which has come in. I'll pick a couple of questions before I go into the next segments like containers and AI and a lot of stuff. So static web app is very simple. So it is also a code which is obviously static content is there. um, Basically there is code changes you make, and there is GitHub and Azure DevOps pipeline support is there, and there is a static content which you have, and you're running. You want to make sure your customers access to the website is all set, and you can obviously make use of the static content, right? HTML images, or the videos, or the CSS which is there. There is no server side things. It are all static assets. Let me give you an example. What do I mean by a static code, right? So let us go back. This is the show which we run, samosachai.net, right? So all you can see on this is on currently running on Azure Static Web App. And basically what is there in this website is nothing but static content. This is an image, this is our images, these are content which is written, and this is again images and content, and these are already hard coded content, right? There is nothing which requires a server side code to be executed to run my application here, right? So that's where Azure Static Web App comes into picture, and it can be you can use it as a free hobby person like this. We are using as a free hosting, or you want to use it as a if you want to use it in a better way with standards and caching and a lot of stuff, you can use it. So simple way to deploy this is this. But if you notice here, as of now, we have a session which is happening on 21st, which is samsajai.net is happening on 21st of November, and we are talking about microservices. We are talking about bunch of things, but that content is not available here. The reason is I need to go to the website. If I have to click next, I have to go to the website, and from this website I need to pick the content which is the next session which is happening, And by the way, if you want to join, I'm going to share this link. So so if I want to go back and build something out of this, right? So if I want to make sure this particular content which is there, whatever we are delivering on 21st, to be available on this website, I need to write an API which will call every time and then bring the data here and put it up here, right? So how can I build that? What support I have from an Azure static web app? I have the static web app. It is all running fine. It is all great, right? So that is where support for functions comes into picture. There is a support for API function. So what it does is basically, if you see in this website, you can call the API for getting the content from the website and then put it here in the format where people can say, okay, whenever they land upon somersetchai.net website, they can see which is the next episode, when is it happening, and how exactly they can join, right? So we don't have to hard code it as a developer. It can build on top of it. That is the mix of Azure Static Web App and Azure Functions. That is the crux here, right? So it gives you lot of ability to build amazing set of products. Because if you think from our perspective, right, use case, we have a use case. We can go back and build that API and put it up here. And imagine similarly, you might have different use cases as a startup, right? You have a static web app, it's simply built for free, and all of this front end is free, and you can run APIs in the back end. Again, you are only paying for the functions which is only executed, basically um, spending you're only spending money only when it is executed. That means whenever somebody lands on this page, then only they will be able to see the data. And also we can store the data in the data every week. We can refresh it as well. So these are the things which we can build with the static web app. So that's about having different set of code and how you can deploy on Azure. Obviously, there are a bunch of other ways as well. Virtual machines, you can deploy through virtual machines. Obviously, there are containers as well, which we are going to discuss, container instance and other things, which I'm not going to discuss container instance here. But due to time, I want to cover only two different things, which is Azure Kubernetes Service and Azure Container Apps. So I will cover in depth with Azure Container Apps because from a startup perspective, this is a very interesting set of things which you can use, and I'll show you why. But Azure Kubernetes Service is very much important if you're a startup as well, because basically you have to make sure that your workload is managed and you are building it for scale, and you are able to make use of all the cloud native tool sets which is out there, so that you can scale your applications and better use of the infrastructure as well. So from a Kubernetes perspective, it's very simple. I will not go in depth with the Kubernetes architecture, and we are going to go in depth 6 to 7 part series in the same slot, where we are going to go in depth with all of these different technologies and different services as well. This is a crash course kind of a thing, which I can call it. So if I have to go back and create a resource and create a container resource, there are two things which I have to create. One is container registry. Container registry is nothing but a place where you can go back and save your your containers image, basically images. Whenever you have a code, you build it, you host that image, you version it, tag it, and store it in container registry. It's kind of a artifactory, and you reuse it, and you, as a developers, you can share it with others, right? So that's what container registry is. It's very simple to create, couple of clicks, and you will be able to get access to container registry. And there are a bunch of things when you go into the container section, right? There are a bunch of things here, like container instance. This is where you can go back and run single containers and other containers, which is one or two containers. And there is Kubernetes Arc, which is where you can run um, on-prem and or any other cloud Kubernetes you're running. How you can make use with the Azure services as well, and then container apps and Kubernetes service, right? So let us go back and say, Kubernetes service. I'm not going to create this one. It's going to take some time, so I'll just show you how to create. So there is a resource group, there is cluster details you're going to give. You're going to pick size, and you want to do manual scaling, auto scaling, and other things. And then there are a bunch of node pools and other things which you can select. There's virtual nodes, which is virtual kubelets, which you can use uh, to scale your application. So this is where somebody was asking how I can use better, right? This is where it comes to, where you can use Azure Container Instance to scale your applications, to scale your pods using the virtual nodes. So basically, if you connect virtual nodes with the Azure Container Instance, you can go and deploy your applications on directly onto container instance via the Kubernetes cluster. So ultimately, your worker nodes in Kubernetes are running with the kubelets. So kubelet is a binary which is running. So you are running with the kubelet, right? So basically, if you use virtual nodes, you can run it through virtual nodes. So there is a bunch of discussion we can have there. It's kind of a topic. And there is access, obviously role based access. There's networking. You will enable a couple of networking, traffic routing, and other things. Integrations and advanced advanced, like you want to store secret on the drive and other things, and resource group infrastructures and stuff like that, and you're going to tag and review and create. So I've already created it. So all it's pretty simple, and I've already created it, and I have the where is it? Kubernetes. Da-da-da-da-da-da. I don't see. Why I don't see Kubernetes? Interesting. Type equal to Kubernetes service. Apply. Okay. Keep show. Okay, cool. This is my Kubernetes cluster. So I have created the cluster. It's up and running, everything. I've also deployed a service. So it's very simple to deploy a service once you have the YAML structure, which is kind of this. Let me open documents. So once you have this YAML file written, that's it. So Kubernetes is all about running pods and all about running containers. So once you have the structure ready, and if you're well versed in Kubernetes, you'll be able to see all of, I mean, you'll be able to understand what all of these things are. And so basically, I've given some images in the backend to run. In the front end, there is a code which is running. And again, this is based on the service load balancer, and I'm using the load balancer. One of the front end is sitting on the load balancer, while the second back end is just a service. That's it. It's not on the load balancer. That means it is not accessible. The front, uh, front end is accessible via the port, right? So I've just deployed this, use kubectl, apply simple command, Kubernetes command. And once you do that, you apply that, and you come to the service and ingress. Basically you go here. um, so I already have the app running on the load balancer. You can see front end load balancer is running. So if I click on that, so I have this application which is running cats versus dogs, right? If you are a cat person, you can go and click cat. If you're a dog person, you can go and click dog. So it's a simple example which is there. So given the Kubernetes, it's complex, right? It is basically, you need to understand writing YAMLs. This is a simple YAML which I have written, but if you are building a microservice application, you need to understand namespaces, you need to understand secret management, you need to understand config management, you need to understand how ingress works, how to do the service discovery. There's bunch of things you need to understand while you build it on Kubernetes, right? So there is going to be a very different set of things you need to understand from a learning perspective. The learning curve is too high when it comes to Kubernetes. As a startup, as a team where you might have people who might not be well versed in these set of things, right? So this is where the next set of things comes into picture, which is Azure Container Apps. So Kubernetes is hard. It gives you a lot of stuff, while container apps gives you the same flexibility. That is, you have containers, and I can use all the set of Kubernetes, specific Kubernetes functions. Whatever you are doing on Kubernetes, you can make use of those things with without going through the complexity. That is, writing YAMLs, understanding the other stuff, right? Without knowing much of the complexity, you are just, as a developer, you can just build microservice applications using Azure Container Apps. So if you see, it is built on the foundation of Kubernetes, Azure Kubernetes Service, and it has support for KEDA, Dapper, and service discovery, which is Envoy. You can see all of these things, right? So most important example scenarios of Azure Container Apps, that is, you have, you want to scale through HTTP request, and you have application backend service application which is running, or event driven application which is running. Those are the scenarios. And by the way, you can use Azure Container Apps in scaling in four different ways. One is the HTTP request. You can see, you can split the traffic 80% on one of the versions of the container. The other versions of the containers get 20% of the traffic. You can basically split the traffic and scale, determine the number of concurrent HTTP requests a particular version gets, right? And background processing as well. There is a huge amount of background processing which you need to do. That exactly it's basically heavy load on the CPU and the memory, right? So there is going to be a lot of processing which happens. So that processing is basically scaling is done through CPU. If there is a load coming in into the CPU, you can set scaling in Azure Container Apps, and you can basically event driven processing again, queues, and also uh, KEDA, where you have scalars, different set of different different scenarios which is there to scale. So basically, it can scale through storage. It can scale through if there is a queue getting filled, if there is MySQL getting filled, all of these things, and obviously support for microservices through Dappers. Dappers is again distributed application runtime, and it is very very important to understand Dappers as well. We are going to deep dive on that. As a startup, you need to know how to make use of all these things to scale your application. But from a container apps perspective, the way it is structured, I don't want to call it as a custom virtual network. Forget about custom virtual networks. Everything is divided into environment, and this environment is divided in, you can see here, I can have multiple apps. I can have multiple apps within the environment, and these apps are running with revision 1 as a pod with multiple containers. uh, Pods is, obviously, we all know, multiple containers becomes one pod, and the same way revision 1 of the, which is the version 1 of the pod, version 2 of the pod, are running in parallel, and you can split the traffic, you can work through it, and it can share all the network and storage within itself, right? So this is this is how environments creates a boundary. So it is creating a boundary, and that is the reason why you can deploy microservices. Microservice 1, which has multiple containers, which is running as a pod, you can have multiple versions of that is running here as well. So there is multiple versions, there is multiple containers within the pod which is running, and this is app 1, app 2, which are microservices. Within that environment, you can have multiple microservices running, and it can discover each other as well because it is in the same environment as well. So, and as you can see, as I told you, it's about revision and having different versions of containers. That is what is depicted, and this is how it works. You have the code, you push it to GitHub, you have GitHub actions running, you have container registry, you build the containers, and you deploy into the container registry. All you need is the containers, and all you need is the container registry. And once you have done the deployment, you can directly go back and deliver this code to Azure Container Apps, right? So this is how you can do it. So this is how revision work as well. So you can have multiple versions, and you can split the traffic between the multiple versions so that you can test your code. If you feel that version 2 is not really good, you can deactivate it and make sure all the traffic goes to the version 1, or version 2 is very good, version 1 is is done, we are done with it, we can deactivate the traffic to it, and we can reactivate it. So ingress traffic splitting, which is also available, which works like this. You can set basically 80% can go to the version 1, 20% can version 2. All these things are available on the portal. So as a developer, right, you are actually not really or as a DevOps engineer, you're not really worried. As a developer, you code, you create the containers, and you deploy, you just push the containers. And once you push the containers, or even DevOps engineers, they build the containers and they push it here, right? So this is a very simple structure. So as a developer, you're only focusing on the code, the business logic. But as a DevOps engineer, you are just running a GitHub action, and the code is getting deployed, and you can all set all of these things within the portal and make sure that you have built it and deployed it right. So this is how logging works as well. So there is revision 1, revision 2, containers running, all goes into the log analytics of Azure, and you can access this. And obviously we have a bunch of things with observability, metrics, alert, streaming, and everything, all of these things, right? And you can see couple of these things are all very specific to Kubernetes. So all of the functionality with respect to Kubernetes, you are making use of all the functionalities, but yet you are not going into the complexity of Kubernetes. That is the beauty of using Azure Container Apps, and it amazes me as well. And there is amazing support for Keda. Keda basically, it's event driven. There are built-in scalars. It is easily you can manage this workload. If I can say, this is how Keda works, right? It can scale through HTTP. It has lot of events. You can see there's a support for multi-cloud support as well. There is Azure Event Hub, Azure Blob Storage, Service Bus, cron jobs, PubSub, MySQL, Postgres, Redis support, anything which is happening, any event which is happening on these set of tools, you can basically replicate your application. And then there is CPU support and memory support. If there is a CPU utilization at this support at this level, replicate your application, which is pod, increase the number of pod. And memory, again the same thing, increase the memory in terms of whenever there is a different thing, increase the replications as well if the app is using certain memory. So this is the support, this is the scalars. If you know about Keda, if you want to know more about Keda, go back to Keda and see what all scalars it supports, what all event sources it supports. There's bunch of events which it supports, from starting from RabbitMQ queues as well as in Postgres as well, and these are all open source, right? These are available. And container apps also supports Dapper integrations. You can see all the building blocks of Dappers, which is service to service invocation, observability, resource binding, PubSub, secret management. All of these things is supported. And if you see this architecture, so there is a service A, there is a service B. Once you enable the Dappers on top of this, there is a sidecar architecture which is running, and all of these things are talking to each other with it can easily find different set of services through Dappers, and also apply couple of Dapper building blocks as well. So Obviously you can build it via, you can access Dapper APIs via HTTP API or gRPC APIs. And as I told you, know, the most important thing is Dappers, because you can build it with one component. The simple example here is, I have the code, I built it with containers, and I apply Dappers on top of that. And basically, if I want to use observability of Zipkin, I can just go back and use Zipkins. If I want to go back and use Agers, I can go back and use Agers. If I want to go and use triggers with Twilio and Azure Storage, I can use it without changing anything with the developer's code. Everything is happening at the other side, and since developer is not touching code, it is not going to fail, right? You know, developers need to keep we need to keep developers away from the code, so that's the thing. So once you keep them away, and everything is managed to with the infrastructure, with the support of Dappers, you don't need to change any code. All you're doing is instrumenting it within your Azure Container Apps, and you are able to use it, right? So this is about, the containers, right? There is, we talked about code, which is Azure App Service, functions, static web app, and then we saw, Kubernetes service. We saw the container apps. So all of these things are still in the application building side. What about bringing in intelligent system to your application, right? So how do I bring in intelligent system to it? So that is where AI comes into picture, and it's nothing but building human behavior into the application. So that's how I behave, right? That's the way human learn stuff. If the machine is learning and you are able to apply that learning and make predictions, that's where AI is all about, right? So key elements, I'll just go through this fast. There are machine learning. This is the most key element to make predictions, right? You have data, you give the data to the computer, and you build models and predictions, and you basically iterate that particular data, and then you draw conclusions from the data, right? That is what machine learning is all about. And there is anomaly detection. If there is you have a telemetry data which is coming in, and there is a alarm anomaly detected in the telemetry data, you're basically sending out a trigger for people to see how exactly this works. So there is a computer vision, the capability of software to interpret the world visually through cameras, video, and images. Right? There is way you can capture all of these information and create a computer vision and build, identify people, facial recognitions. You can identify a couple of things like the forms and other things, right? Then there is natural language processing capability of written and spoken language, responding in different kinds of languages, and creating a neural voice and all those things. And there is a conversational API AI, which is basically agents. So um, there's bunch of things which is there, and I'll not spend much time on teaching what is machine learning and what are the different supervised, unsupervised machine learning. Basically, you can go back and learn this. Uh, the most important thing here is you have the data and you are training a machine the way you train any kid in today's world, right? You are going and training a kid. These are the colors, these are the, these kind of things are called bottles. These are the things we call it as mobile phones. Within that mobile phones, these are the kinds which is called as iPhone, and these are called as Android phones, which is Samsung phones or different phones. So basically you're classifying things. That's how you teach anybody, right? So that is how machine learning works. And this is a simple example as well. We have different set of flowers, and the data is fed into the system, and data basically learns, and then it identifies whenever it is thrown something at it. It classifies this particular flower as kind of family it belongs to. So that is what this whole thing is. So here is the link. Basically, if you want to learn AI ML, you want to understand what all I spoke, like the supervised, unsupervised, getting started with AI ML, here is the link where you can go back and try it out. And here is the link where you can go back and learn algorithms, which I talked about. There are different algorithms, the classification algorithm, and there are a bunch of algorithms which is there. But from an Azure AI perspective, right, there are three different buckets. One is um, building, you can easily bring AI to your application by using already pre-built models. So Azure AI provides cognitive service and other services where you can consume the APIs and SDKs and bring AI to your applications without any hassle, without building your own model, without building your own stuff, because it is already been pre-built. And there is the second bucket where there is a lot of content available out there. The content can be in PDF within an enterprise or within a startup, anywhere. The content can be in a PDF, in a Excel sheet, in different formats. How do you make sense of all of this data, right? So how do you see this data? So that's where knowledge mining comes in. You feed all the data to the knowledge mining. It creates a kind of a structure for you to search and build knowledge on top of that. And also you can consume that knowledge into your Power BIs and your basically build it into a different set of analytic tools which you can use. And again, the last is the machine learning, where you can build your own deep learning solutions, your own models, which is machine learning models, and you can go and deploy those models and use it. So all of these things basically are running through APIs. The first bucket, which is already pre-built, which is already ready for consuming. You don't have to go back and use it. You can just go back and just take it up and use it. That's what bringing AI is to your application. The second one, you have the data, you feed all the data and you get the extracted data there. And the third one is obviously bringing your own ML. So I'll go one by one. I'll try and see if I can demo some of these things. I know I'm just over time, so give me 10-15 minutes. I'll show you a couple of things. So there is, these are cognitive services. There is vision service, which is from a image and other things, right? You are recognizing face, you're recognizing forms, you're doing couple of things. And there is, there is a speech, right? Text to speech, speech to text, transcriptions. There is a search, which I talked about, and there is a language as well, right? You are translating language and other things, and decision making, anomaly detection and other things. So from a vision API, right, image processing algorithm to, this is how it works. So basically, if you just show an image to a computer system, it is actually telling you whether it is building roads or outdoor street, what it is, people are walking, busy street, what it is showing. So this is how the structure shows. Let me show you the a simple demo of this. So I can go back and I can use the API, and if you go back to the my collections, right? So here I have actually given you explore computer vision. So if you go to this collection, right? So in this collection, you can see there is bunch of things getting started with image analysis, right? So you can just go and use Azure subscription and sorry, go to this exercise, launch exercise. So basically, if you launch this exercise, you can see there is a bunch of like portal. You go there and you can run couple of code which is there. It is consuming the API, and basically you can see a couple of things, right? You can see these images and you can make what these images are doing. So I don't want to spend time here. I want to spend time in building a custom image. So this is custom vision. So basically, how you can build your uh, own model and how you can build your own service, right? Say for example, I already have one grocery thing. Let us rebuild it. So I'll call it uh, my my project and something. And again, I'm doing the classification, right? Type is classification. Basically, I'm trying to classify different objects. So I'm going to do the classification and single tag per image. That is what I'm doing, but not multiple tag. I'm using domain. I'm telling food is my domain. This is where already pre-built as well we have. So what it will do is it will train this model classification. You are not writing any code. And also, I'm not a data scientist, or you're, if you're not a data scientist, all you have to do is to understand basics. Classification is to classify things. Food is where your project is all about. So it's easy. Go and create a project. So it creates a project for you, right? So I'll add image. Okay. So I'll go and say, okay, train through apple, all the apples. I'll copy all the apples, and I'll tag it as apple and upload. So all apples gets uploaded. All apple images are here. So you can do it with any other classification you're trying to do, right? So this is another example. So let me go back and say, okay, let's go for bananas, and say, okay, bananas. I'll tag it as BANANA and say banana. Done. So I've uploaded all the banana images which we have. And last but not the least, I'm going to train it with oranges. So basically what I'm looking at is, what is my, if I now upload a banana picture to this particular test, it should say it is banana, right? That is the expectation here. I want to classify. So it's basically teaching a kid, this is orange, this is banana, this is apple. Now tell me what this is. Then it will think like, oh yeah, this is apple, oh yeah, this is orange, right? That's how kids learn. Similarly, uh, that we are teaching the computer system. So basically we have the system here, and all we need to do is I'm selecting all the images and say train. So quick training. It will take some time to train this format. So that is the reason why I already have my project ready. Uh, Let me go there to my grocery project. Okay. So now, you know, um, I already have the training done. Um, if I go here, performance, after the training is done, after the first training is done, it will show me, okay, this is image count, this is what we have precision and all those things for each of these precision. So we know what it is and all those things. So now I can publish this. So if I have to choose to publish, so for this, I'm also using what? Wikibytes con. What is that? This is basically my Azure Cognitive Service, which is there. Let me go and say type. Uh, I've used Cognitive Service multi account. So what it does mean is I'll just have to go here and say Cognitive Service, and I've created a Cognitive Service for myself. Instead of creating each speech, language, and all those things, I've created multi-purpose use. So basically one cognitive service where I can use it with all of these things, even including OpenAI, right? So all of these things is available with it, right? So that's what I am doing, and I'm coming back to this one where I have the cognitive service running and prediction resource, and I publish, and this gets published. When I say publish, I get a URL. I have the image, I have the key. All I need to do is to use this key and use the URL, and you know just send the data to it, and it will reply back to me whether this is a apple, or this is this is orange or not. Like the example, let me go do the quick test. So I'll browse from my local system. I'll say orange. I'll take this one and upload. It is basically testing now, and it is going to tell me what this image is. So probability, this is going to be a JSON format. So when if I use this URL, if I use this API, I'm going to get a JSON format back, which with orange as a probability as 99.5%. It is taking like apple could be, it could be an apple, but orange is 99.5% probability. And that's where you can use these use this as an API. All you need to know is the Python code, and which will write a code to call this request and get the JSON format, read this JSON format, and say okay, 99% probability, which is the highest probability, orange is the highest probability, and I am just going to go back and push it in my app saying this is an orange. So that is how classification models can be built with the custom vision, right? So similarly, you can build with rest of the things, right? Where you can go back and as I told you, this is where we were using, right? Upload image, train and evaluate, get the API and use it with the probability. Similarly, you can use it with facial detection, face recognitions and other things, right? So this is already pre-built, it is available for you to use it. And there are this is an example which I'm just showing how you can use facial recognition, and it's basically you can identify person from a facial recognition. There is you know forms where you can use it as a form perspective, form recognizers and other things, and speech to text, text to speech, translation. There is an amazing video, actually this is amazing video. uh, I just want to spend only some time on this. Basically, what they do is basically all of them are talking, and you can see it is basically converting their speech to text, and not just speech to text. It is also recognizing who is the person who is speaking here, and basically converting that data, and it is basically noting it down. And now it is not just noting it down. At the end of this whole thing, it can also translate this particular whatever notes they have taken, everything into different languages. And that is you can see that it is converted into different language where the other person can also understand. So that's the ability of translation and how you can use it in the app. I could have done. I have the demo, but I don't want to spend much time on here because I want to spend time on the um, in the questions. So knowledge mining is also same. You, as I told you, there are a bunch of data you have, PDFs, docs, PPTs, and a lot of different formats. All of these things, you if you upload it and if you ingest it into the knowledge service, which is the Azure Search, it basically you can also use this with the cognitive services which we have, which is facial detection, language detection, and other things. And then it extracts this into a document, and it creates a different level of data which can be used. And this is an example how a company uses it, but I don't want to spend much time here. This is one of the example how knowledge service been used by one of the customer. So machine learning is very important. So you building your own way, right? We provide data scientist in a box. So let me show you that as well. So if I come back here, okay. So if I go and create Azure machine learning workspace, I've already created it. So if I have to go back and open some workspace, let me open this. So there is a studio. So if you open the studio, um, you will see this is the workspace of mine. So all I've done is basically I've created an automated ML. So it comes as a data, a data scientist in a box. So everything you need to manage your ML ops and manage your models, build more models and use it as an endpoint in your application, which one to use and all those things, and compute, because you need compute to build your own models, right? Because it's large data which you have, you need compute to build those models. So I have bunch of compute which is enabled. um, could be cluster, right? I have cluster which is running, and I have endpoint which is there. So all I've done is come here, added a new data set, some data I've added, and I gave what all things I need, and then created all of these things. So basically, this is some kind of data which is there. So I've just put that example in the chat as well. This is what machine learning studio looks like, and it provides you with all kinds of support from a from a compute perspective, building your notebook as well, creating your own set of things, and you can run it here as well. From execution, you can run particular cells. We all know how to run Juniper. And then there is you once you built it, there is an endpoint. So once you have the endpoint, you can use this endpoint just like how you use the custom endpoint which I showed you right here. If you come here and custom service, custom vision endpoint, if you go and click here, you can see there is an endpoint which is here, and you can use a set of keys. Similarly, you can use this endpoint with keys, and you can go back and see how to consume this particular model which you have. So that's about Azure machine learning. um, from a monitoring perspective, there are a bunch of things which is there. We saw application insights. Application insights can provide you the metrics, the logs, and the trace, and it can provide you the metric side of it. And monitoring is, we also have container monitoring with part of the Azure monitoring for containers. And you can see here there is application infrastructure, Azure platform, and custom sources. With all of these sources, Azure monitoring can be used, and you can see here there is a it collects metrics, logs, and trace and changes. So basically, all those things which is required from a observability perspective, all the three pillars are there, and it collects all this data. And then you can see there is insights which it builds, which is application insights, that is tracing, understanding about distributed tracing, understanding about how these applications are running, and basically trying to see how applications mapping each other and talking to each other. All of these things can be built on with this insight. And container insights as well, getting the information about container endpoints and other things, and VM and network and all those insights. Obviously you can visualize this data using the Power BI, the different dashboards, Grafana, and other things. And you can obviously do the analytics as well. There is a log analytics which I showed you while I was talking about container apps, and respond, basically alert actions and other things. Integrated platform, the event hubs, logic apps, and import and export APIs, where you can integrate with different set of tools. So even before I go to next segment, I just want to show, uh, from a container apps perspective, just a couple of things. So I've built so container apps when we talked about it. So it is very simple to build it. So just go to container apps. Um, just select the resource group which we are talking about. So here is the resource group. So this is the resource group which we are talking about. Container apps name, right? So we give you some name, and this is the container environment. You can have different environments. So I am just using the default environment. So here is where you can just select container registry and give bike app, and I can use my app which is already there on my container registry, which is a simple Blazor app, which is version 1. I don't. I'm just using a simple CPU and memory. I'm ingressing it. I want to access this, accept from anyone, and I want it on port 80, right? So I just go there and I just review and run a new container app, and it gets running, right? So simple. So this is how you can go back and build container apps as well. I just wanted to show you this because I've just gone over out of time, so I just want to make sure you see this as well. So one, all I did was I had a code on my container registry, and I pushed that container registry on to this app. So this basically picking my container which is there in the registry and deploying it here within that environment which I talked about. And within that environment I can deploy multiple containers, and with the enablement of dappers on top of that. For example, I'll just show you. um, I've already built it for our usage. So here, so if I go here, so you can see there's an app which is also running. I've already built this, but I just want to show you this. So this is the app, Blazor app, basic Blazor app, which is there, and there's a counter, and you can do click me and other stuff. So there is fetch data, weather data, and other stuff. So this is a simple app which is there. I am just deployed there, just with the container apps, and this is how you just go here. You can see dappers. We can enable. You can enable ingress. You can enable revision management. You can go here and say, okay, how many revisions you want. You are deploying another revision. So basically we are creating a new version, new revision. So you go and create a new revision of this. So it's basically scaling from 0 to 10. You can have maximum replica. So all of these settings are here. So basically you can build a simple microservice app with this specific thing. So coming back, very important, as I told you, this is the link where I've copied everything, whatever I could learn from a startup perspective, right? I can. There are much more things to do as well. So Parth will share the link in the chat, but much more to do, right? There is Azure products. If I have to show you, as a startup, you will have to go back and see this with we have 200 plus products, so not everything is required from a startup perspective. I might not be using all of this Spark and all those things. So if you go to the containers and if you understand what exactly the things you want, these are the container apps, functions, container registry, Kubernetes service. These are the things which you might need. And from a tools perspective, what are the things I need? And from a compute perspective, what are the things I need? All of these things. You don't need a quantum. You need a app service. Maybe not use, or maybe use on the static web app. Probably not use scale sets, right? So all of these things, because most of the startups, we all focus on building it on PaaS layers. We use a lot of PaaS layers and AI perspective as well. There are a bunch of things you can do with AI. Computer vision, custom vision, which I showed you, face APIs, form recognitions, which I showed you, where you can recognize the form, identify the fields in the form, um, you know, bunch of things like speech translation we saw as an example, right? How people can talk to different things. So cognitive search and other things which we talked about. So this is how you can actually explore all the products we have and make a note of things which you require, which you don't require, which I feel, these are the list of things which I feel is the fastest way to get your application up and running. And then you iterate on different set of services, different set of things while you deploy it onto something. So any questions? I know there were a bunch of questions, and let me take that. Let me stop sharing my screen so that I can bring this uh, here on my screen. Okay, there are questions. So please share questions now. I'm happy to take. Yes, that is SKU. I did mess up on the SKU. Um, Hi, app service support Node.js based application, how the code build process work in app service after deployment. Yes, there is a question on Node.js support for app service. Let me share that in the chat as well. So here you go. So there's a quick start as well. So I'm going to share that link here. That is something which you can go back and take a look at it. And there is a question, is there an app backend with regular usage, which is more economical? App service or function? When to use functions? So functions to be used when you have asynchronous event-based triggering. And app service is something where you have application which is always running. So that is the difference. So if I have an application which is always running, I want to have application which is always running, that's where I'm going to go for app service. If I want to spend some time on functions, where I can trigger later as well, right? For basically there is a trigger which comes in and it gets triggered with the time triggers as well. You can also set it up in terms of if there is a change happening in the Cosmos DB and this particular thing changes in the Cosmos DB, that's when I need to run. So this is basically an asynchronous, and you are not really it's not basically you're waiting on something, right? So that's something we can get it. So recording will be available. We're going to because going to we will upload it. Okay, there is a link. Are there any more questions from the chat? Or people can unmute and ask questions as well. You can basically unmute and ask questions now, right?
Hey Vivek, hi, Shantanu here. First of all, thanks for this great session. I just wanted to understand, like, I mean, we didn't go much over the container instance today, but I just wanted to know, like, I mean, like we went in depth on the Azure apps for containers, and we also have a concept of Azure container instances. So again, my confusion is, what use case demands which particular component of the Azure.
Got it. So I didn't go through the Azure container instances basically because if you have a single container, you just want to run and you just want to keep it, basically you want to trigger it later, just like that. That's when you use container instance. So if, for example, if I have to give you, um, um, in a pod scenario, okay, there is virtual kubelet, I talked about it. Azure container instance is available, and within that container instance, let me share that. Wait, might have the Azure container instance, right? So the difference is nothing. So basically container apps is built for microservices. It is built on an environment. It is built on uh, built with the support of Kubernetes. Container instance does not support Kubernetes uh, functionalities, right? So container instance just runs a simple container, one single container, and it executes it and comes back, and you're basically not doing much there. It is only a trigger. Again, it is just like a Azure web app service with containers, right? So similar to that, the same service is called container instance. But the most important use case of this will be, I'll show you. I'll share the screen. Just give me a minute. Let me share the screen. You can see my screen. This is where um, the most important use case will be the burst scenario. Okay, so I have Azure, container instance uh, working with virtual kubelet. So if you take the Kubernetes world, master node is talking to the worker nodes in Kubernetes through kubelets. And if you build it as a virtual kubelet, that means if the kubelet is installed on a different set of servers, and which is container instance for here, and if I bridge that connector with through virtual connectors, then I can easily scale my application, right? So I don't have a diagram for that here. How it can scale is basically, there is a, say for example, you are at Times of India, and you have gone out there and you have shared some marketing collaterals with everyone in India, right? Saying that today you are going to do this offer, this is the website you have to go, and this is things you have to apply. And imagine there is a lot of traffic which comes to your application. Kubernetes as a structure, you have worker nodes, and your worker nodes gets full, and with the memory and with CPU, then how will you scale your Kubernetes? Either you have to do pod scaling, or you have to do the node scaling. The node scaling will take time. Pod scaling will happen only as long as you have the infrastructure. And if you go into a node scaling, then it becomes a problem. So to make sure you take care of the you take care of that scenario, we have something called as virtual kubelets, which will get integrated into your Azure Kubernetes service. So what happens is, whenever that scenario comes in where you are hitting lot of request, all the pod request will get transferred into the Azure container instance. And in Azure container instance, you can run more than 40 instance or 50 replications or 30 replications of the same. So that is where Azure container instance comes into picture. uh, I don't have the diagram for this, so I hope you got the point, right?
Yes, Vivek. Thanks a lot.
Let me share my own video, which is there. Virtual kubelet. Mm-hmm. Mm. Any other questions? Which is there? While I search for anyone, any other questions we have?
Hi, Vivek. Uh,
Yeah.
I'm Darren from Goa.
Uh-huh.
I have a scenario wherein my company has come across a client which does not want to use Azure services as such, although my team has been developing with Azure services from the start. So is there any kind of functionality with this latest set of features that Azure has provided, like containers, and even one of those which you mentioned, which was knowledge mining. That
Mm-hmm.
was an interesting feature. So does Azure offer anything like an export functionality that gives that to be run on another client machine? As in, like, I'm talking about a client, for example, the government of India, which wants to use its own servers and not rely on Azure or any other services for that matter. So does Azure have something like that, which exports the infra setup?
Yeah, we I will have to go through this again. Basically, so you are saying you want to use knowledge mining service, for example, but in a in a in a closed environment. Is it
Yes.
is it that? Uh, it it comes as a, you can use it as a arc. Kubernetes arc, and use it as a containers Azure Cognitive Service comes as a containers and you can use it as a arc, but I'm not too sure on the how this can be set up and how you can use it. I will have to go back and see. Do one thing. Can you just drop an email or drop a chat note on the LinkedIn profile so that I can go back and spend some time with the products and come back to you. Like, is there any way we can help you out there?
Okay, sure, sure. Yes.
just just drop a note, so that will help me as well, like to come back to you with the right set of answer, because I do because it's kind of different off scenario. uh, I'm not also sure how we can
Yeah,
use
yeah.
it.
It is a difficult scenario because even we had to face it when dealing with the client. That's
I know.
yeah.
Do share me other details so that I can talk to the products and come back to you.
Yeah, sure, sure. Thanks a lot.
And I have shared, I have shared, Shantanu, the link to my talk, which is on virtual kubelet. So that is where Azure Container Instance is very powerful. The burst scenarios. You can basically take a look at the talk.
Yeah, I was just looking at that video. Sounds great.
It has a demo actually, which shows I was able to scale to 50 to 30, 50 plus instances in the service. Basically a replication of that service. It was a difficult demo because it was not running, but you can make sure how difficult it was to run on the system without internet. Any other questions from the audience, or else I know it was almost 2 hours. I had to go through a lot of things. Even I had one more demo. I just made sure that I move through the demos. But yeah, just let me know if you have any questions, or reach out to me on LinkedIn. Happy to share. And there is a form where you can share the feedback so that we can look at look at these things differently. And by the way, there is going to be deep dive session on Azure services next week from Vinayak as well. Um, Not next week, this week itself on 21st, right? Frijesh or Parth, 21st. Okay. Um, it is deep dive on all the
It's on
services. So
21st. Yeah.
21st. So it's a
Yeah.
deep dive on all the services. Just go through that. And this is a start of a series, basically. We are going to go back and go deep dive into each of these things which I discussed now. So that is something which we are going to spend time. And there is a question, will you or do you know if there will be any talks on Azure AI in detail? Yes, there will be. Specifically, as I told you, we are going to spend a lot of time in each of these topics which we have discussed. We're going to spend time on custom vision, computer vision as one set of days, and speech and translation as other things. But if you are looking for uh, quick thing, you want to know what this is and you want to go through it, uh, I have already done that series. We're going to go even more deep dive in our series which is coming in, but I'll just share the link to you. So I have pretty much covered all cognitive services here in my GitHub repo. You can go through that as well. So that's the link. Cool. If there are no questions, then we can close the session, Rajesh and Parth.
Yeah. Yeah. Thank you.
Okay.
Thank you so much, everyone. Thank you, Vivek, for this wonderful session. So we'll see you on the next edition of Scale Up Masterclass session. Yeah.
Yep.
Bye.
Bye bye. Thank you all for joining in.